Yeah, line now.
Perfect. Welcome everyone to the second workshop of ETH Toronto. Super excited to kick it off with Anjali and Chetan today from the ICPHub. Um, and yeah, just as like I'll act like a clock for you all, and there's only 1 day left for the submission. And we've also already have a couple bills flowing in. We're expecting a lot more and a lot more to be approved and for you to be seen on the builds page. But yeah, super excited to support ETH Toronto, ETH Women once again, make it accessible to all the developers around the world. It's not a closed event anymore. Definitely, it's an online plus offline event. But anyone and everyone from any part of the world can come in, showcase their project, and be a part of the hackathon. And yeah, with that being said, there's also inline blockchain futuristic conference, the tickets of which we would be giving away. But yeah, without further ado, I'll pass it on to Anjali and Chetan. Um, Folks would love to start with a quick intro of yours, then maybe setting the agenda for the workshop, and then getting on to the juicy stuff you have today.
Yeah, thank you so much, Mishika. And we're very excited to be here. So I'm Anjali. I am the Developer Relations Manager for ICPHub Canada and US, and I'm joined with my colleague Chetan, who is the Developer Relations here. So it's wonderful to see so many people building on ICP, and this is a second workshop in the E Toronto and E Women Hackathon, which is going on. And the first workshop we discussed a lot about the canister management, the basics of ICP and everything. And now this session is going to be a little bit advanced session where we're going to talk about the Motoko language and the Motoko development. So as far as the bounties are concerned, I think I discussed in detail about the bounties in the last session as well. So just to give a little clarification, so for all the folks building on ICP and trying to get that ICP bounty. So you have to basically come up with a project which utilizes and leverages the CK technology of ICP blockchain, probably by linking it to Ethereum or Bitcoin, maybe through NFT projects or anything where you use this cross-chain interoperabilities. And we're really excited and looking forward to seeing all what you've built. So having said that, I think Chetan, I'd ask you to begin the session today. Thank you so much.
Yeah, sure. All right. So, hi guys. Probably like we can start now. It's already 5 minutes since we started. So, I guess here till now we have many projects, and probably we are expecting some more. Like, obviously there are 2 days left for submission. You can still wrap up your projects, deploy upon the mainnet, and in case you are having any queries or any doubts, you can just always ping us. So today we are keeping the session which covers mostly all the things that you will be requiring for building our projects. And in case you are having any doubts that needs to be covered regarding that as well, we are still here. You can ask in the chat box. Yeah. So first of all, we'll start with basic data structures that you guys must have encountered till now, and we'll just give a quick revision to that, and then we can go ahead with the basic project that we are planning here for today. So first of all, I guess these are we are not spending much time because we want to focus more upon the project side only. So I'll just give a quick wrap over the most basic data structures that we need to use today. Yeah. So first of all, arrays. I guess yeah. So I'm just assuming that everyone is a bit familiar by now because we are in the advanced stages of this Motoko strict lecture. So arrays are nothing. Arrays are the just another complex data structure for handling different types of like we can handle integers, we can handle in a like strings, text, anything like that in a single variable. So that is one thing. And like if you want to, yeah, probably I need not stress more upon these basic things. So array, a type of array is a group of similar elements that are stored together. We want to store different numbers in a single type of data structure. Array is the best choice for us. Then we go for same goes for the text, same goes for the float and all of these values, right? Now I'll just be covering only those data structures that are required for the building the project, right? So there are hash maps. So I'll just cover the hash maps. Wait. Yeah. So what are hash maps? Hash maps are the data structures that are helpful in storing the key value pairs. So let's say, okay, so if you are mapping some objects, if you have done data structures like objects, you know the concept of key value pairs, right? Then when we destructure these objects, similar way, when we go for hash maps, we import them. Like why are hash maps used? So I'll just show you with one example here. Um, 1 second. Is my screen visible?
No.
One second.
Yeah, it's visible now, Chetan.
Okay. Okay. So yeah, hash maps we were talking about, right? So in the sorry to have you like so the in Motoko, hash maps and the trie maps are the most important ones that you guys need to follow. So what hash maps does is hash maps helps us in storing the key value pairs. Key could be type of key that is nat, text, and principal, and V is the type of value that will be storing in that key, right? So let's say we are here then in this type student we are defining some hash here. Then in that key, let's say we are defined some name, and the value is going to be in the text format. How do we use it? We first of all import this hash map from our base library reference, which is, so what base library is? Base library is a library given by foundation only, which has all the data structures, all the natural types, or everything included in that. So if we have to do it, we import it from the base library only. Then what principal is? We import principal. Why do we do it? Like principal is something you would be needing when, let's say, you are a controller. I'm just assuming many things by now that you must be knowing that what actors are, what controllers are. So what you are as a controller can control the identity of a canister that you are creating. All the control, when you want to update it, when you want to delete the data inside it, all the operations that you want to do, that will be done using as a principal ID only. Let's say you define the actor here, and then in that you are the type of that actor is student, and now we are giving the key value pairs as name, age, favorite language is going to be a text, and then graduate is going to be graduate or not, graduate or yes for a student. These are the characteristics that we have defined. Now these all we want to store these data structure, we want this can be imported inside a hash map. So what's the syntax of doing that? Let map is equal to hash map dot hash map. This is the previous syntax, this is the old syntax that we used to do. Then but similarly this is also relevant till now, we can use the updated ones as well. Like if you go to the original documentation by now, like you will be seeing the new type of syntax that we have here. But I guess both of these are still relevant. So this principal dot equal and principal dot hash, this is the common thing that you guys need to follow while writing the syntax. So hash map is something that you are importing from the base library, and via this dot operator you are referencing this hash map and using this for principal and the student, the value that you are storing here. These all things could be, why are we doing hash maps here? So the most important thing, why we use this data structure most, is that the time complexity of doing this hash map is O of 1. Like the time complexity is constant for all the deletion, updation, and insertion operations. So this is the reason that the most common data structure we use, and without doing any delays in our program. So this is the reason that we use this. Now these all operations, like if we want to, so how do we add something? So let's say the map is the variable and you want to add some more value inside it. So you will be doing that map dot put. If you want to get something out of that hash map, you do map dot get, and if you want to delete something, map dot delete. Just these are the simple operations that you guys need to be performing, right? I guess these all must be more, these will be more clear when you will be using this in the project thing. I'll be showing you the project that we're doing right now. One second. For for doing this project, I would suggest that if you guys are having this VS Code already installed in your systems, that is good, like having all the DFX setup. If someone is doing it for the first time or have some issues while deploying the project, it's better to use it while using in this session. It's better to use Motoko Playground. So here itself we'll be checking out what exactly the code is. So first project that we are working on right now is a CRUD operation. So what CRUD operations are? So CRUD operation means that how we can create something, how we can read something, how we can update something, how we can delete something in an application that we are doing, because these are the common operations that we need to do, right? And probably we'll start with that example only. And while using that example, it will be much more clear to us that how these data structures are helping us. So let me just import the code for that.
Chetan, we lost your screen again.
Yeah, I am just sharing. I'm importing the code for that.
All right. Okay. Okay.
Meanwhile, if you have any doubts, you can just keep writing in the chat box here.
We would be posting all the social media links in the comments, pinning it in the comments for everybody, and in case you have any queries or previous workshop, you need to see the previous workshops, we'll be sharing all the links in the comments section.
Exactly. So yeah, so first of all, from where is, like, if you want to take some references as well, that how with this code being imported, so you can just go for this build section in Motoko developer docs. In that you will be seeing some sample apps. In that further you will be seeing a CRUD example. This is the first application that you guys need to be doing every time when you are like, and like if someone is a beginner here, they will be getting the feel of what exactly data structures are in ICP and how actually do we use it, because data structures are always common in all the languages, but it's just that way we are using it in specific language. So without wasting any time, if someone is having any like if someone is having VS Code and systems installed, you can do it in this VS Code only. It's much preferable there. But yeah, I'll also probably do it there only. You can just go along with me. Yeah, so just give, I guess everyone must be having this link with them. Anjali, if you can post that in the chat
Yeah, sure.
for the superheroes. Yeah. And superheroes is just, it's a fancy name given for this replica we are doing. So you can just have this command and we start running this command here. The replica has been initialized. Now, I guess there's some issue with this. Like cloned, no? Yeah. First of all, you have to clone the example here. It does take a bit of time. Meanwhile, we can just start taking a look over the code. Yeah. So I was talking about this base library reference, right? Now, what exactly is this? How we are importing it? So you can see that list, option, try, and nat32. Even a basic primitive data type is being imported from base library. So you just need to be very careful while doing that, right? Otherwise, you'll be just referencing it and you will not be able to use it. So what exactly a list is? Now, it's the way that you do it. You just go for list data structure. Again, apart from hash map, ones that are the others that are common is a list one. So you can go for this list. Yeah. So what are this list? Purely functional, syncly linked list. again, linked list, so you must be knowing about linked list, right? It helps us in attaching one data type and one, I would say, one optional pair value with another one without like arrays are using a lot of spaces and we are not able to address them at, like we have to waste a lot of space. But with the list, we can have like reduction of space while using our programs. So that is the reason why I use linked list. In a similar manner, a list of type list is either null or an optional pair of a value of type t and a tail. So it stores the address of that and also stores the value for that. So while address is getting stored, we are able to exactly reference that address via present in the via present in our like base address itself. So this is the reason we don't need to like waste a lot of space. We can reference anywhere in our blocks that we have stored. So here itself, it is written that difference between a list and an array is that array is stored as a one contiguous block of bytes in memory, and a list is scattered around without the elements having to be adjacent to each other. So as I've said, we can reference it from anywhere just with our base reference, with our base address that we have stored. The advantage is that we can use more memory efficiently by filling the memory more flexibly. Now, that is the reason, like this is the one of data structure we quite frequently use. Then there's something called as option. So what options are? Let's go for there. One second. You go in the advanced types, optional types. Yeah. So here you will be getting something called as option, and yeah, in Motoko, like we know that there is special value called none. So basically, in other languages like TypeScript, also you must have seen that we get sometimes when we define it, we get the data type returned as undefined. Here, basically, we don't really get undefined. We get, if we are not really sure about what exactly are the value that we're storing here, so we get a null value out of that. This is a special value called null. That is, this is just a replacement of undefined from other languages. So this is special value called null used to represent in the absence of result. This is helpful when indicating that function returns nothing. The value null is of type null, which only contains one value null. So this is like if we are not very sure that what exactly is getting to be returned here, and we want to return an empty element, instead of getting undefined here, we are returning a optional value here. Then we go for nat32. Again, it's just a specific integer type only. Now coming to this, I'll just import this code now. I guess this is cloned now, and I go for this. First of yeah, so the dfx is starting here. Now we go for the code here. Npm install for installing all the node dependencies. I'm just assuming a lot of things are already like built since we're on the last stages, so probably it would be simpler for many of the folks here, those who are attending the session. Now we deploy this project. Here you can see where exactly is this project I'm talking about. Let me just bring this one only. Yeah. Now we deploy this project. Here is the SRC folder. In the superheroes, you'll be taking this CRUD example. It is creating the canister. You get a canister ID for this project on a local system only. It takes a bit of time. So yeah, meanwhile, I'll just get you the like what you call this actor. So actor, what actors are? So just giving a short review that what actors are. Actors are basically a container in which our canister gets shipped, and after canister gets shipped, this container helps us in wrapping up the block and feeding all the data inside the blockchain. So in other languages, you must be knowing about RPC calls, RPC JSON calls. But in ICP blockchain, we don't have like basically RPC provider. We just directly go via this actor model only. and vector model itself is responsible for adding the data inside the blockchain. We don't need any specific RPC provider here, because now what exactly was a differentiating factor that ICP was used for. So ICP itself is a cloud. So we are not really talking dependent upon some other RPC servers that will be handling our data. So we can directly interfere with the blockchain here. So that is once, like we can, like actually we as a controller can add or delete some operations like consensus mechanism or anything like that we can do with the blockchain using this actor model. So that is the reason we have it, and we are avoiding any RPC nodes that used to be and takes a lot of computing costs as well, right? So I open this and you get the canister ID. So you can see that these are all the operations that we were trying to do: create, delete, read, and update. And like you must be seeing that like these are all the functions: create and read, update, and delete. Now what exactly, how have we written it? So first of all, we'll just, this was the backend that I showed you. The UI was the one that I this backend candid UI was the one that helps us in handling all the APIs. Like Postman helps us in handling all the APIs, right? In a similar manner, for the ICP blockchain, we use candid UI. Now, first of all, actor starts here with the actor superheroes. Then public, this is the type of superhero identifier. So public type superhero ID. Just superhero is nothing. You could have named it anything else as well. We are just naming it for our, like, just a fancy name for it. So then now we are defining that what exactly are we want to store here. So for the superhero, we are given a name. We are giving a name here and the superpowers that we want to add or delete here. So we create a superhero first. Public function create superhero. And first of all, I guess in the basic lecture also we covered that. In the first lecture we covered that every single function has to be done asynchronously. Then this superhero itself is a type, and in this so basically, why how are we referencing all the data? Like it could be natural number also, it could be text also. So this try is something that helps us in storing key value pairs like hash map only. Try is another reference from hash map. So if you could have used you could have used hash maps also, but try is just one level ahead of hash maps. The syntax is here itself. Like you have the superhero ID, and for each superhero ID, you will be getting a different superhero. So you create this superhero. Let like first of all you create this, and okay, I could add. So basically, you have the superhero ID, and you are just adding all the functions here. So in the similar manner, we were doing hashmap dot equal and hashmap dot text. Similar value, we are doing this try dot equal here. So this is helping us return the superhero ID. And yeah, so basically this key is getting stored here for that superhero ID for that particular superhero that we are getting here. So if you want to just read this, like what exactly is the superhero that you are returning here, so you get this. And how are we doing it? First of all, it finds that what exactly are the superheroes that we have stored here. Then I told you, like, this is the syntax. In the hash map also, we were doing hashmap dot equal and hashmap dot text. In the similar manner, here we get this ID, and for its equal. Similarly, if we want to do some update function, you just go for another. If it exists, then just return exists. If it does not, then we'll be updating, like if it does not, we'll be updating it with these values, with this new ID. And if it's not present, so we will just return it if it is actually existing only. But if we want to delete it, we just delete it via option. So why are we doing it via option? We got that if it's not present, we get a null value, right? So in the similar manner, we are doing this option here. So option is helping us, like if it's not present, we get a option value that is getting helping us get a return as a null here. So I guess this was a pretty simpler. This got the example was a pretty complex one. I want to show you one more example here. One second. For this CRUD only, it's much simpler one. Let me show you one second. The one that example could, like, because of this superhero classes, you must have got a bit confused here. Uh, This example must be much familiar with you, no? Okay. So instead of just take that superhero for a second, revert it on you again on that. First of all, you just go for normal members only. Let's say you were having some basic DAO you were having, and in that DAO, I guess everyone knows what DAO is. So in that DAO, you need to add, delete, or remove some member, or you would want to just check that if that member is present or not. How do we do it? First of all, we just take a hash map here, let members and hash map dot hash map, and then in hash map dot hash map is like it's the syntax that we use here. Then principal for that, as we are a controller here and we are installing the member inside that principal. Then 0 is basically the index ID for this hash map data structure. Then principal dot equal and principal dot hash is something that you can just you have to write. We can't really cover that. Why are we doing it? It's just a syntax that you guys need to follow. Now, if you are creating this function of add member, so why are we writing it public shared caller? So caller is basically the principal ID that you are calling here. Like this function is a shared function, and anyone in this canister can use this. Like basically, this project would be so. Let's say this is a DAO project. This has different canisters. So each canister can talk with each other. So basically, public shared caller function and then add member. So caller is one who is the controller here. It's referencing to a principal ID itself. We add a member here. So member data type we have already created. So member is something that member is this one that we're talking. So members are already created. Member will be having the text and the name here. So each member should be having a different name and different member. We have given a property of name and age. So we are importing it in this project. You can see this types.mo file. Like here, a new file will be created. Types.mo. And from here, you get this member data type, right? Now it should run fine. Yeah, you can see the error has been resolved. Basically, this type is something that is importing everything that a member need to be written. Now, how we add the member? So first of all, we do a switch case statement here that if member is present, we are trying to add the member here. So we have already taken a data structure. If the member is not present, we just do it with the data structure members.put, and we return it as an okay. This is some like error handling that we do in JavaScript. Similarly, this is how we do error handling in this Motoko language. Members.put. If the member is already present, we just return that member is already existing via this return hash error. So error and this okay are coming from this result data type. So result is helping us in getting the okay, the true and the false value for that result, right? Now, if you want to get this the member updated, if the member does not exist, so it will be returning as member does not exist because we can't really update something that does not exist. Instead, what we'll be doing is we update this with a member.put. As I've shown you that in hash map, if you want to add something or update something, you do put operation. And then if you want to remove a member, similarly, first of all, it will be checking that if member does not exist, it will be throwing us this via this result library that member does not exist. If the member exists, we can just do it that members.delete. Then it will be returning as an okay statement. It means that the function has been completed. And if simply you just want to return the member, what exactly are the member that are stored here? So you get a members.get. Like this is the switch case that we have applied here. If the member does not exist, just throw this error. If this member exists, just throw the member itself, like members data itself. Now, if we want to get the data of all the members, so it's another data structure that you guys need to follow. This is iter. So basically, iter helps us in iterating over the array that we have stored, right? So iter just helps us in iterating for this array, which will be having all the members, and in that we will be returning all the values here. And number of members, if you want to just calculate, you go for members.size. So I guess this is a normal CRUD application, like how exactly we add or delete something. These are all the operations. You can do countless number of operations. Like you can get the members, you can count the number of members. There are many things that you can do, but as per today's lecture, we just wanted to cover that how we basically cover all the basic operations. Like, and I'm pretty sure that hash maps and try maps are the data structure that are going to be used mostly in your projects. So yeah, this was something that I was going to cover. Now we're going to be doing one more project by Anjali. Anjali will be doing that, and yeah, Anjali, over to you now. Yeah.
Yeah, thank you so much, Chetan. I think it was quite an informative session. Everything about the CRUD operations on Motoko. And I'm sure that people are at this level where they would be appreciating
Yeah.
all the usage of these functions. So thank you so much. I think continuing with what Chetan has taught, I mean, a lot of things which Chetan has already covered regarding the data structures would be used in my example as well. So let me share my screen first.
Also, guys, we're just assuming that, like, since it's a last, we're just giving a disclaimer that if you're feeling something somewhat complex, like the data structures, you're feeling complex to use. The thing is that we are assuming that it's the last stage of the hackathon, and you must be pretty much done. Those who ever are building the project. So yeah, Anjali, just giving a context to that. Yeah.
No, yeah. Actually, so please try as we are like ready to answer all your queries on the Discord group, on the official Twitter group. I've posted all the links here. So feel free to ask for coupons for cycles. We are providing, as an ICPHub Canada, we are providing some coupons for you to claim for the cycles. And the process is clear. If you want to get more clarification, you can reach out to us. So yeah, please keep building, and we are very excited to see all your projects which you've built. So yeah, continuing with today's this hands-on program. So I think I'm going to use a similar tool which Chetan used, the Motoko Playground. So let's type Motoko Playground in the Google. The first link appears. Just open that link. So Motoko Playground is actually a replica of the development environment, but browser based. So I'm assuming that the people who are watching the workshop are at an intermediate or an advanced level in Motoko development, in ICP development. So they would have a setup installed on their systems where they have the DFX command line installed and everything, and they're working on some VS Code or some other platforms. But still, for the general public, this is a very hands-on and a very good tool. So in case you do not have the environment installed yet, so you can always go to this Motoko Playground. There are a few sample projects which have been shown here, and some we could import from the GitHub. So when you click on the other tab, it says import from GitHub. You see the official repo for GitHub is mentioned here for the Definity Foundation. And there is the sub-repo of examples given here with the master branch. So currently a counter application is opened. So the directory structure says motoko/counter/src. But the project which we are going to discuss now is a simple to-do app. So I want to discuss the code of building a simple to-do app in the Motoko language. So for that, we already have the code with us. Instead of counter, you just have to type in simple -to-do. Simple to do /src is already there, and we just need to import this. So let me zoom in a little. Yes. All right. So as you can see that the code for a simple to-do application is on the screen. So I chose this application because it's a very intuitive and a very simple application to build upon, yet it covers all the important aspects of building on the ICP protocol. So I think it is going to serve as a very good example. So a lot of things have been already discussed by Chetan. So I will not try to repeat it. But to just give you a reference, we are beginning our code by importing all the libraries which we would be needing in the code. So for developers, it's always a good practice to write the import statements as you need the library. So write as you go. So for now, we could just see that we are going to use a map, a hash map, a natural number, an iterator, and a text library. So we are importing all these libraries from the built-in base library of Motoko. So I think the syntax for any language doesn't matter. So the syntax you can always, or you can always see, and you can always adapt. But for any programming language, the semantics of it is what matters. So as we know that Motoko is an actor-based language. So we have to define an actor before we start coding. So for us, we have named the actor as the assistant, and we start off by mentioning the name of the actor, and then we are going to define our own data type. So there are some existing data types. For example, we have text, we have natural numbers, but we also have some user defined data types, as we have in all other languages. So even if it's Java, JavaScript, .NET, or Solidity for that matter, any other programming language, all support user defined data types. So we have created a data type called as to do. And this to do is, you can consider this data type as an object which has two properties. One is description, which would be a text, since this would carry the description of the task which we want to do, which we want to perform. And of course, we are going to associate it with a Boolean. So we've named the Boolean as completed colon bool. So obviously, as you know, this is the format for writing the user-defined data type. So the completed Boolean would actually carry a true or a false value. So whether you have completed the task already or it's a pending thing for us. So once the task is completed, you will mark it as true, completed as true, and you will see that we are going to deploy this, and we're going to see that a tick mark, a small tick mark, appears in front of the tasks which we mark as completed. Now this is followed by a nat hash function. So now, as we are dealing with a hash map, we know that you have to convert the textual representation into a hash value. So this function simply takes in the text, takes in the number, and converts it into a text, calculates the hash, and stores it. We would appreciate the usage of this function a little later when we are trying to manipulate the functions of a to-do app. For now, you just understand that we are converting the number into a hash value and storing it. Now, here we, in the line number 19, we are creating another variable, to-dos, which is a type of hash map. And the key value for that hash map would be a number, a natural number. And the to-do values, the value part of that hash map would be the to-do data type, which we have defined above. So what this actually means literally is that to-dos variable is going to hold values, numerical values, and against those numerical values, it is going to hold the task description and the task status. Of course, we need a counter for creating more and more IDs. We are going to begin the ID with 0, but this is the next ID is like a counter variable, a natural number, an integer, not an integer, a numerical number basically. So it's next ID, and it's going to start with 0. And next is for us a query function. So as Chetan has also explained, we have query functions and we have update functions. So query functions are basically read functions where we are only reading the data and not changing the state of the blockchain or not updating the state of blockchain. So these are cheaper in terms of execution. These are cheap functions. And we always mention the word query before these read-only functions. So we've written the word query, and we want to basically, as the name is suggestive itself, get to-dos. That means we want to get all the tasks which we need to do. So definitely it's an asynchronous function. As we know that in Motoko language, we support this asynchronous mechanisms. And what we are going to return here is a to-do. Basically, we're going to accept a to-do and we're going to return the values. So we are going to use an iterator to iterate through the to-dos values, the to-do variables, and all of that is going to be displayed in the form of this user-defined data type. So basically, when you call get to-dos, we are going to be returned with the numerical value and the description. That is what it does. We are going to deploy the code and check all these functions for ourselves, but we're just going through the code first. So it's a very direct code. I mean, at this level, when we are trying to submit our bounties and everything, I'm sure that this would be really intuitive for you at this stage. So in case you're stuck somewhere, please feel free to post your queries in the chat box. Chetan, please let me know if somebody has any queries regarding the code, and we can also answer your queries later on. Now, another function would be to add a to-do. Of course, we are going to start our code after deployment. We are going to start with this function itself, because we are going to add our very first task, and then similarly, we are going to add more tasks through this function. So as expected that this would contain a description, the counter is auto-incremented through the code, and we are just going to need the description from the user, the description of the task. And we are going to, very straightforward, we are going to be, as we know that we have created a hash map with to-do's name. So we are going to put the ID as the key, and the value would be a to-do data type, user-defined data type, as we had created in the beginning of a code. So for against that ID, we are storing the description sent by the user, and also in the beginning, we are setting completed to be false, which makes sense because while we are trying to add new tasks, of course, they would be in the non-completion mode. It is only in the next function where we can mark a particular task to be complete. For this, we are, intuitively, we know that we have to pass an ID of the task, which we think has been completed by us. So if it's task number 2, if it's task number 3, because again, as programmers, we know that writing a text here will not make sense because the text could be different in spaces, commas, and everything. And always the primary key is the one which we use for updating the code. So now here we want to update the status, and it is not a query function, it's an update function for us. And for update functions, we do need the primary key. So for us, the key would be the ID, and we are going to get the description first, and we're going to check whether the description is there. I mean, for that ID, that means the ID exists. If we do not have a description passed to us, that means the ID is invalid. Could be a case where we only have probably 5 tasks in the app list, and we are trying to pass a 7th or an 8th ID. So in that case, no description would be returned, and we would understand that it's an invalid ID and you have to ignore it. But in case you are returned with a description, then what you have to do is you have to put that ID. So that is what we do, how Chetan explained that this is how we do update, right? In a hash map, we again put the key value, and for the value part, we put the same description, but only thing which changes is the Boolean value. So for completed, which was false earlier, now we are going to pass a true statement. So it is going to be true now. So, so that is it for the complete to-do function. Basically, we are marking a particular ID. If that ID exists, we are going to mark that ID as a true Boolean. And if the ID doesn't exist, we are not going to do anything. You could update this function when you are trying to, if you are trying to replicate this or trying to, work on this code. I think a good idea would be to return a text error message in case you fail to get the ID. I think it makes more sense to send a user message that, the entered ID was incorrect, or there is no, this ID doesn't exist, it's an invalid ID. It's always a good idea to send error messages to the user so that it's more clear where the problem is. Now, moving on to the next function, we have the show to do. So it's a display function. Basically, it doesn't do anything. So that's why it's a query function. It's a read-only function, and it returns a text. Now here you could see that we are trying to format the text. So we are using a /n. As we know, as it is common in all the terminal-based these languages, this /n represents a new line, a carriage return. So basically, everything which appears after this would appear in a new line if it's started with this. So to-dos would appear in a new line, and then we are starting with a for loop. So for all the to-do values, so since we know it's a hash map, so we are going to use an iterator for it. And this to-do variable is going to contain the local information, value by value. So we are going to display this local information, but only the description part. And if it is completed, if the to-do.completed is true, that means if the task is completed, we are going to append a tick, as we could see. So the hash used in the Motoko language is for concatenation. So whatever output we have, the output already we have is a description. But we want that if the task is completed, that description should be followed by a tick. And then we append a new line so that the next task appears in the new line. And if it is not completed, then you should not do anything about it. But if it is completed, then we should show a tick for this. So I think we could appreciate this function more once we deploy the code and once we check it in the output window. But for now, we understand that it's kind of a query function, a read function, which will show you the exact status of your tasks on the to-do app. And finally, we have another function which uses a map filter, and it is the clear completed function. So in case you feel that you have added a lot of tasks and you want to declutter your app and you want to remove all the completed tasks from there, which makes sense, right? There are 6 tasks, you have already performed 3 of them. So one idea could be that you could put a tick in front of those 3 tasks, and it would show you that what is your progress. But you could also want to remove the completed tasks from your list completely and to be only shown the pending tasks. In case you want to do that, you can use the function map filter, which is available in the Motoko language. So what this map filter does, so it will accept a variable. So in our case, it's the hash map to do, and we pass a function. So let me explain you about the map filter function. How does it work? So apart from sending in the argument, we send a function to a map filter, and we mention that if the value of that function is true, then it should return a null. If it returns a null, you have to discard the entry. But if it does not return a null, then you have to update that particular entry with the new entry. And what is going to be that new entry? It is going to be the output of this function. So I would repeat this again. So map filter, it works in a way that it accepts an argument and a function. So for the function, in case it returns a null value, then you are supposed to ignore that entry and discard that entry from the input data type. But if it's not a null and it returns a value, you have to update that data type to the new value. So I hope this makes sense. But once we just look at the deploy window, I think it would make this would be really helpful. So yeah, let's go to the deployment section. So I'm just installing this. Let's see. Yes, it's requesting for a new canister ID. So once you deploy the code, whether it's in your local systems, in the Visual Studio Code, or you're doing it here, so basically what this does is it creates a canister with a canister ID, and it installs the written code over here, and it installs this code in that particular canister, and it returns the canister ID to us. And it also, Motoko and the ICP platform actually gives us a very good backend UI for us to test our applications. So if you could see, if I could just move this a little. All right. Yeah. So this is Candid UI. Okay, this got zoomed in. I think this is sufficient. Yeah. So we are going to basically check for ourselves whatever functions we have discussed right now. So starting with, as I told you, this is going, add to do is going to be the first function which we are going to try. So let me write a task, a simple task, for example, drink water. and I'm calling the function. That means I'm executing the code. So yes, so the output has returned me the ID for my task. It's 0. And let me say I need to attend a webinar. Again, I'm calling the call function, and it has added with the ID 1, it has added a new task for me which says attend webinar. Third task for me would be to complete my assignment. Let's see. So yes, wonderful. So it has added the this task also with ID 2. And let's add one more task. Maybe visit a friend. Yes. So now we have actually in total 4 tasks. So what add to do has done is it has added all the tasks along with a numerical value, an ID. Now I just want to go and have a look at all my tasks. So I would go to the show to dos function, which was a display function for us, and call the query function. Now, as you can see over here, to dos and all the tasks which I've added appear here in new line by line. But you could see that no particular task is actually completed by me right now. It's all pending. So you cannot see any tick over here. So all the tasks are pending status right now. Now let's complete a task. So for that, I need to use this function as I discussed. I need to pass the query of one of the tasks and mark it completed. So let me pass number 1. So what I am trying to tell the code here is that I have completed task with ID 1. So now when I've done this, and now I would again run the show to dos function. So yes, now as you can see that once I run the show to dos function, you could see a small tick appearing on the task with ID 1, the attend webinar. So it's very important for us to know the IDs of all the tasks. Here the IDs are jumbled up. It's not shown sequentially, which it should have. But it appears as the ID for it would be 2, but it is 1, and the webinar, attending webinar. So we should remember the IDs, and it tick mark appears next to the task which we have completed. And now finally, if you just want to have a look at the pending task, and you do not are not affected by what you have completed, and you want it to be removed. So we have a function with map filter function, which is the clear completed. So it does not accept an argument. Reason being, we already know which tasks have been completed. We just need to clear them off. So let me call this function. So it is not accepting any arguments, but it is an update function for sure. And now it has done its work. For us to see that, we need to again call the show to dos function. So you can see the moment I click on show to dos function, the attending a webinar task has disappeared from here, and it is only showing me my pending tasks. So that is it. I think it's a very beautiful example of a simple to-do application. So I would encourage everybody who is the intermediate stage, or it's going, or as a beginner also, if you want to try and understand the code, the data structures, the map functions, I think it's a wonderful example, and it's there on the official Definity repo of the GitHub. And please go try this function, try all these functions. And in case you're stuck somewhere and you have any queries, feel free to contact me or Chetan for it. And I think it was a wonderful session. Thank you so much, guys. Over to you, Chetan.
Yeah, thanks a lot, Chetan and Anjali. That was definitely one very elaborate session, and I hope the devs can take back a lot from this. With that being said, we don't have any questions for now. But yeah, we've dropped all the relevant link for the devs, and like I said, we've less than 2 days left for submission. Um, so yeah, put on your hacker hats on, and good luck if you've already submitted to the hackathon or you're about to submit to the hackathon. But yeah, if you have any question, feel free to reach out to the ICP team, to the DoraHacks team. We'll be more than happy to connect you with the right kind of folks for your question. Um, but yeah, again, thanks a lot, Anjali and Chetan, for your time.
Thank you
And
so
thank
much.
you, everyone, for attending, everyone who tuned in. Bye bye. Take care.
Bye.